Oh, welcome to this another question on an organic thing on oxidation. This is again for Tompel, and again she's not giving me the year, so I'm going to have to try and fly blind on this one. All right, CO cobalt ions catalyze the oxidation of 2,3-dihydroxy butane dioate ions to methanoic acid, or sorry, methanoate ions, CO2 and water. What's the property of transition metals that enables them to do this sort of thing? Well, they can gain or lose electrons. Okay, and they're a good place to pick up electrons and dump off electrons. Now, I guess we could call this property. They have a variable oxidation state. Okay, so there you go. Draw the structure of this guy. Right, let me try my best at this. So we have butane dioate. So 1, 2, 3, 4, and there's one O8 and another O8 on the other side. So that's butane dioate, and apparently there's a hydroxy on number 2, which is this one, and number 3, which is this one. And there you go. That is 2,3-dihydroxybutane dioate. Now, this is the tricky bit, I guess, isn't it? How are we going to react this with oxygen from the cobalt, or the cobalts being the oxidizing, or the catalyst for the oxidizing? How are we going to use cobalt to do this? I don't know off the top of my head. So it says we get methanoate ion. So let me draw a methanoate ion over here. This looks like this. Okay, there's a methanoate ion right from this. I use this. Now, obviously, you're going to get 2 of these, aren't you? Because there's 2 in the molecule. So I'm going to say 2 of these. There you go. Now, let's dig around on here. There's 1 CH. Oopsie daisy, that's wrong. Let me go back. There's only 1 carbon. So I'm going to get this bit plus an H. Is that it? Yeah. That's 1 methanoate. And let's do the same on this one. It's going to take that away. So what's left then? Well, we've got 2 C's. Okay. So we're going to get 2 carbon dioxides. And we've got OH and an OH. That's H2O2, isn't it? All right, but I'm going to put it like that for now. We've got an H2O from these 2, plus another O. Okay, so that's how it stands at the moment. All right, so now I've got to see how many carbons I've got on the left. Sorry, how many oxygens? I've got 2 times 2. I've got 4 oxygens here. I've got, this is going to have to be an O2, isn't it? All right, there's 4 more there. And I've got 2 oxygens there, so I'm going to get rid of that one. And I'm going to say there's 2. Where's my pen? 2 waters. Okay, so there's 2 there. I hope this makes sense, but we'll see in a minute, won't we, if it makes sense. So I'm going to say that's my original guess, as it were. Okay, now let's have a look. So we have 4, 4, and 2, so that's 10. So I'm going to say we have 4 oxygens to start with. Now, I've only looked at the oxygens, so I think that's my guess. Okay, let's have a look at the hydrogens. We've got 4 here, 2 here. Oh, we've got another 4 here. Now, one is set, so this can't be 2. There's only going to be 1 of those. So let me restart that one. So there's got to be 1 water. So this is wrong now. I know there's going to be an O there, though. Okay, so how many have I got now? 1, 2, 3, 4. How many oxygens on the right hand side? 4 here. 2 times 2 is 4, plus 4, plus 1 is 5. So this makes 5 oxygens. Okay, there's 6 there. Is that right? 5. 4, 4, sorry, 9. There's 9, there's 6 there. So that means I'm going to have to use 3 of those. How many carbons are good? Hydrogens are 1, 2, 3, 4. Oxygen's good, yeah. So I think that's the answer I'm going to go with. Now, Lompo, I don't quite know what you wanted me to do with this. There's no special secret here. I think what I did here helped realizing what bits and pieces we have. Okay, so what did I do again? I took one methanoate ion and two. So I know there were two of those. Okay, from that, I also know there must have been two carbon dioxides. From this, okay, there's H2O, all right, H2O. So from this, I knew there was, well, there's H2, and that's set, isn't it? So there must have been one water. And if we work backwards and we count the number of oxygens here and whatever, we need three more on this side. Okay, I hope that makes sense. I'm not very happy with the answer, I must admit. I don't think there's not other than what I've done. I think you just got to work through it. Okay, maybe I'm wrong. If you can think of something better, go for it. But I don't think there is really. It's one of those things you just plow through until you get it right. All right, I hope this makes sense. If it doesn't, give me a shout. All right, bye bye.